Hello, and I hope everyone is having a fantastic weekend. So I told you I would make a video for you talking about some two-dimensional kinematic stuff. Let's keep this short and sweet and go ahead and get started. Okay, so what we see here is we have a parabolic motion. We start over here and we are going at some initial velocity, some initial speed here, the magnitude of the velocity. You can see that it has an x component and the initial velocity has a y component. So the initial velocity in the x is the velocity in the horizontal distance direction, and the velocity initial in the y direction is our vertical velocity. So as this object undergoes projectile motion, and we are going to assume that acceleration in the x is equal to 0 meters per second squared, because we're neglecting air resistance here. So the velocity will not change in the x direction. And you can see as we get higher and higher and higher, we notice that the velocity in the vertical direction is slowing down because we do have an acceleration from gravity. And we will say that the acceleration in the y direction is equal to negative 10 meters per second squared. Negative, it's pointing down. And notice when we get to the highest point, also known as the apex, the velocity in the vertical direction goes to 0. So we're going to use that a little later on in this problem. Now, once it passes the apex, it starts coming back down, and notice the direction of the velocity in the y direction changes. So on its way back down, that velocity in the y is pointing down. So we are going to have to make that negative. So let's just get right into it, and let's work a problem. Yeah. Okay, so let's see, what do we got? Let's say that an object is fired or kicked or shot or released or whatever at some initial speed, and we'll say that initial speed is, let's not use that one. We'll say that the initial speed is 20 meters per second. So the magnitude of the initial velocity is equal to 20 meters per second, and it is launched at an angle of, I don't know, say 37 degrees. Okay, so if you're ever just wondering how the heck do I start this problem, well, I suggest that you draw your triangle. So here we have our triangle. We have the initial speed that it was launched, and that's equal to 20 meters per second, launched at 37 degrees. So here is the horizontal component, the x direction, which is the velocity initial in the x, like that. And we also have the opposite side of this triangle. This is the adjacent side. We have the opposite side of this triangle, which is the velocity initial in the vertical or y direction. Same thing. So we want to find, for the first part, is how fast is it moving in the horizontal direction. So we can go ahead and just write our list of variables. So we have the x direction, and we also have the y direction. So everything under this x direction is going to have, in terms of we're going to talk about it in terms of the horizontal components, and the y direction in terms of the vertical components. So we can list our variables. So let's see, we have velocity initial in the x, we have velocity final in the x, we have acceleration in the x, we have the range that it goes, how far does this thing land from the point that it was launched, fired, kicked, whatever. And we also have the time. And we can do the same thing for the vertical direction. We have velocity initial in the y, we have velocity final in the y, we have acceleration in the y, we have delta y over the total motion. So this is the total displacement. And we also have the time. Now, we can go ahead and start filling out some of this chart with things that we know. We know that there is no air resistance, so there is absolutely no acceleration in the horizontal direction. So that's going to be equal to 0 meters per second squared. We know that the acceleration in the vertical direction is pointing downwards, and that's the acceleration due to gravity, so it's going to be minus 10 meters per second squared. With this motion, the object will land from the same height that it was launched, so my delta y, my displacement in the y, is going to be 0 meters. All right. So you can see we already got a lot of this already filled out. So let's go ahead and just start up here. So let's do the velocity initial in the x direction. So velocity initial in the x is going to be equal to the magnitude of the initial velocity. So that's 20 meters per second times the cosine of the angle in which it was launched, and that's 37 degrees. And so 20 times cosine of 37, this is 16 meters per second. So let's go ahead, we can put a box around that, and let's start filling out this chart. So it's 16 meters per second. And let's find the velocity initial in the y direction. So the way you might see a question would be, first find the horizontal component of the initial velocity, or what is the initial velocity in the x direction. I'm talking about the same thing. And then you might be asked to find the initial velocity in the vertical direction. So this is going to be 20 meters per second times the sine of the angle in which it was launched, and that is 37 degrees. So 20 times sine of 37 is 12 meters per second. And if you're still wondering where I got this from, all I did was just use SOHCAHTOA. So for the adjacent side of this triangle, velocity initial in the x, it's the adjacent side, so cosine theta is adjacent over hypotenuse. Solve for the adjacent side, you get your equation for velocity initial in the x. And similarly, we will use this first part, so sine theta equals opposite over hypotenuse, and solve for the opposite side, we get our expression for velocity initial in the y direction. So we kind of got a bit of a freebie here, since we know there is no acceleration. So acceleration is the change in the velocity, and since there's no change, then that means that the initial velocity in the x direction will be equal to the final velocity in the x direction. So we can go ahead and just write that out. So you can see we really haven't done all that much, and hey look, we are almost done. And I forgot to put that one there. So 12 meters per second. And since time is the same in both directions, and it might be good to add that the x component or the horizontal component of the motion is completely independent of the vertical motion. But the only thing that will be the same is time. So when we find one of these, we already got the other one. Okay. So let's go ahead and do some of that. So the first thing that I would probably want to do here, well, you can find velocity final in the y, you can find time first. It really does not matter. So let's go ahead and let's find the final velocity. Why not? Okay, so we will use equation 4 for that. So I got an initial velocity, I got an acceleration, I got a delta y. Didn't talk anything about time, so I will use equation 4, which is velocity final in the y squared equals velocity initial in the y squared plus 2 times acceleration in the y delta y. Now I go back to my list for the y direction. I say, is any one of these equal to 0? And yes, it is the delta y. So when this is equal to 0, this whole term goes to 0. So the velocity final in the y squared is going to be equal to the velocity initial in the y squared. Take the square root of both sides and you get a plus or minus out front. So let's see, what direction is this pointing? Oh, remember, it's on its way down. We do not assume that the final velocity over the total motion is 0 because it's hit the ground. We don't do that. So we know that this is pointing downwards. So let's see, the velocity final in the y is going to be equal to negative 12 meters per second. Alright, so now that we have the final velocity, it is very easy to find the time. So let's see, let's just do this. This was to find VFY. And now let's find time. So I would use, let's see, I got an initial velocity, a final velocity, and acceleration. Let's use the easiest equation, and that is equation number 1. So velocity final in the y is equal to velocity initial in the y plus acceleration in the y times time. So let's just go ahead and solve for time. So t is going to, let's see, subtract that over to the left hand side. So velocity final in the y minus velocity initial in the y divided by a. So acceleration in the y. Let's keep it consistent. Cool. Okay, so velocity final in the y minus 12 meters per second minus 12 meters per second divided by negative 10 meters per second squared. Our units work out, so let's see. This is minus 24 divided by 10. So what do we get? 2.4 seconds. And we can go ahead and put a big old box around that. So let's see, 2.4 seconds, 2.4 seconds. All right, now we want to find how far down range does this thing go. So we want delta x. So we want the range. And to find that, well, there's got to be a delta x in it, so let's use equation Number 2, that's the easiest one. It's the only one that we can use, and that says that delta x equals velocity initial in the x times time plus 1/2 acceleration in the x t squared. And since acceleration in the x is equal to 0, this whole term will go to 0. So we are left with delta x equals velocity initial in the x times time. So that is going to be equal to 16 meters per second times our time, which was 2.4 seconds. And so what do we get? We get 38.4 meters. Easy peasy. Now, there are a couple of other ways that we could have found time. So let's just talk about them, because there's not always just one way to solve these problems. Okay, so what could we have done? We could have said that delta y equals velocity initial in the y times time plus 1/2 acceleration in the y t squared. Now, delta y was equal to 0, so we have 0 equals velocity initial in the y times time plus 1/2 acceleration in the y t squared. Now, I'm doing this one because there were a lot of questions about how I did this. Okay, so let's just go ahead and subtract. We'll subtract this entire term over to the left-hand side. So what do we get? We get minus velocity initial in the y times time equals acceleration in the y t squared over 2. So there's still my 1/2. This might make the algebra a little bit easier for you, so maybe if you want to write it like this, absolutely fine. Cool, so we're solving for time. So let's go ahead and divide by t, and let's see, that those t's canceled, that t cancels with one of those, so we are left with minus velocity initial in the y is equal to acceleration in the y times time. See, don't forget, there's still a t left over there, over 2. And now just do some algebra. Let's multiply this 2 over to the left-hand side and divide by a, so you get t is equal to minus 2 times velocity initial in the y divided by a. And you'll see that regardless of what you do, you will get the same answer here. So minus 2 times velocity initial in the y, which was 12 meters per second, divided by minus 10 meters per second squared. 2 times 12 is 24, divided by 10 is equal to 2.4 seconds. So that's just another way of finding your time. Now, so let's just go back. So we got 38.4 and 2.4. Cool. All right, so let's put it into our list here, 38.4 meters and 2.4 seconds. So you see, all we have done is just a couple of 1D kinematic problems, and we were able to fill out all of this. Now, on your quiz and test, you might be asked to find what is the max height. How high does this thing go? Or what is the vertical position of the apex? I'll probably just say find the max height. So what are our apex conditions? So at the apex, the velocity final in the y direction must be 0 meters per second, or else that wouldn't be the apex. Cool. So we can just treat this as a normal 1D kinematic with the initial velocity in the y. Same thing, it was launched, was it 12 meters per second. The velocity final in the y at apex is equal to 0 meters per second. The acceleration in the y, that has not changed, so that's minus 10 meters per second squared. We want how high up does that thing go, our delta y, and we have time. So there are a couple of ways that we can do this. So one way is to use equation 2, which says that, oh wait, no, not equation 2, because then we'd have to find, we're finding time, not delta y. You know what, I like equation 2. Let's see if we can do anything with it. So delta y equals velocity initial in the y times time plus 1/2 a t squared. Now, we have to be very careful. We are talking about the apex, not the total time. So if you wanted to find how high does this thing go, we're going to need to find time. So we can use, we can exploit our symmetry here. So the left-hand side of the motion, the object going up, it's going to spend the same amount of time going up as it does going down. So we can say that the time to the apex is equal to the time total, time that it took to make this total motion, divided by 2. That we can do. So t apex, time to the apex, is going to be equal to 2.4 seconds divided by 2, which is going to be equal to 1.2 seconds. So our time to the apex is 1.2 seconds. That would be one way of doing it. Another way that we could do it, if you didn't want to think about it like that, is, well, let's use this equation. Let's use equation 4. So that's like, this is one way. And here's another way to do it. So this is using equation 2. Well, now that we found the time, well, let's just keep going with this. We can find the final velocity. I'm sorry, we can use equation 4. Which is velocity final, the y squared equals velocity initial, the y squared plus 2 times acceleration, the y, delta y. Okay, so we ask ourselves, are any of our variables equal to 0? Yes, the final velocity, 0. So we have 0 equals velocity initial in the y squared plus 2 times acceleration, the y, delta y. So let's just solve for delta y here. So what do we get? We get delta y is equal to minus 2 times velocity initial in the y squared divided by, nope, not 2. It's just minus velocity initial in the y squared divided by 2a. 2 times the acceleration. So I subtract this to the left-hand side, and then I divide by 2a to isolate my delta y. So here we have minus. Now be careful, we are not squaring this negative. So what was my initial velocity in the y? 12 squared divided by 2 times negative 10 And what do we get? 144, that's 7.2 meters. And you can also put this time to the apex in here, and you will also get delta y that way as well. So, you will see a question asking you to fill out this. You'll definitely see a problem on it. Definitely your test on how to fill out that table. Something we did in labs, we did it in the simulation lab, we did it in the practical lab, and multiple times in class and on your recitations. So I hope everybody has a great weekend, and I will see you on Monday or Tuesday. And as always, happy solving.